Okay, this video is about how do you deal with prime factorization question involving how perfect square and perfect cube. These are some of the ways that they ask. Find the smallest integer k such that the cube root of 324k is an integer. So some of you may be confused by what does it mean by cube root of 324k is an integer. It's the same as asking for 324k is a perfect cube. Same apply for the rest of the question. Okay, let's look at how do we deal with each question individually. In order to understand what is really going on, we need to know what is the definition of a perfect square and a perfect cube. A perfect square is a number. A number is called a perfect square if all its power of its prime factor is a multiple of 2. Same apply for perfect cube. The only difference lies between them is one is perfect square is a multiple of 2 and perfect cube is a multiple of 3. Now, let's look at how do we deal with the first question. Okay, the first question was asking for 324k to be a perfect cube. From a previous video, we know that 324 is actually 2 square times 3 to the power 4. Since we want 324k to be a perfect cube, we have a number at the back here. Okay, from the definition of a perfect cube, we need all powers of its prime factor to be a multiple of 3. As you can see here that the two prime factor that we have, the power are not multiple of 3. So we are trying to make everything become a multiple of 3. Let's look at the first situation here, 2 square. To make 2 square to become a multiple of 3, we can make it to 2 cube. That's the faster that you can have. So k has to be at least a 2. Since 2 square times 2 will actually give you 2 cube. Okay, so then we look at 3 to the power of 4. 3 to the power of 4, 4 is not a multiple of 3. So to make it into a multiple of 3, we can try making it to 6, which is the shortest that we can have. So what we need will be another 3 square. So you can double check that if k is 2 times 3 square, 324k will be equals to 2 to the power of 3 times 3 to the power of 6. Now you can see that all the power is a multiple of 3, therefore it's a perfect cube. And since is the lowest that you can get, so k will be the smallest that you can have. So k will give you 18. So the answer for this question will be 18. Okay, let's look at the next question. The next question is talking about how do you make a number 198m, square root of 198m is an integer. So this is the same as asking for 198m is a perfect square. If you remember just now that we said that a perfect square means that all powers of its prime factors must be a multiple of 2. In this situation, we're at 198. From the previous video, we know that 198 is actually 2 times 3 square times 11. Now we want 198m. So we have m, which can be any integer, to play around so that we can make all the numbers become a multiple of 2. So to do this, what we can see is that 3 square, the prime factor 3 has already have a power 2 that is already a multiple of 2. So what we need is actually just 2 and 11. So therefore my m is actually 2 times 11, which will give me 22. You can double check by looking here that 198m, if m is 2 times 11, what you'll have will be 2 square times 3 square times 11 square. And this will, all the powers of this prime factor is a multiple of 2. Therefore, the smallest integer that you can have such that 198m is a perfect square is 22. Okay, let's look at the next question. The next question is asking about how do you find the smallest integer L such that 324 divided by L cube root is an integer? This is the same as asking for 324 over L is a perfect cube. Notice the difference between question A and question C. One of it is we multiply by K and we want 324K to be a perfect cube. In this situation, we are asking for 324 divided by L is a perfect cube. The difference lies in we can't increase the power, but now what we are doing is we try to decrease the power. So from here we know that 324 is actually 2 square times 3 to the power of 4. And since you want 324 over L, this will have this situation. Okay, looking at here, in order to make them into a perfect cube, we want all the powers to be a multiple of 3. But now we can't increase the power from 2 to 3 because L is an integer. So what we can do now is that we can reduce the power all the way to 0. Since 2 to the power of 0 is 1, and 1 is actually 3 to the power of 0, 2 to the power of 0, which is actually a multiple of 3. So my L will be 2 square. And the next number that I have is 3 to the power of 4. 3 to the power of 4. To make it to the multiple of 3, we can reduce the power by 1, which make it 3 to the power of 3. So in order to make it 3 to the power of 3, we need a 3. And my answer will be 18. You can double check that 324 over L, if L is 2 square times 3, you will have 2 square times 3 to the power of 4 divided by 2 square times 3 to the power of 3, which you will have only one prime factor, and the prime factor here has the power of 3, which is a multiple of 3. So 18 will be the answer for C. Now, let's look at the last question. We want to ask for the smallest integer n such that square root of 198 over n is an integer. This is the same as asking for 198 over n is a perfect square. So previously we know that 198 is actually 2 times 3 square times 11. So 198 over n means this. Okay, notice that the only thing that has a prime that has a multiple of 2 is actually 3. So in order for 198 over n to be a perfect square, what we need to do is to remove the 2 and 11. So my n will be 22. You can double check that 198 over n will give you 2 times 3 square times 11. If n is 2 times 11, you have 3 square. And 3 square is a multiple of 2. So my answer for question D will be 22. That's all. Thank you.